Okay, so today we're going to take a look at the Sennheiser EW300 radio microphone. It's one of these typical presenter cordless microphones running at around 800 megahertz that you'll typically find in presentation halls, that sort of thing. So we found this in a dumpster in school. This is the True Diversity Receiver EW300 G2. And it seems like a very nice receiver. It comes with these lovely little antennas and a big display and a couple of buttons that didn't work, which is probably why it was thrown out. I was able to get them to work only if you pushed extremely hard, like so hard you risk breaking the circuit board. So I thought I'd take a look at it. And what I found was that measuring the voltages on this little board with the LCD and buttons, it's a 5-volt design. The buttons are little gold-plated PCB traces. I can take one of them off here. So you can see those are the actual buttons. And one side is pulled up by a resistor, probably around 10K, 4.7K. That's on the actual controller board, so we won't take a look at that. But when I measured the voltage, because one of these little holes up here is connected directly down to the pad for the on button, even pushing really hard, it was only pulling down to about 2 volts. And the only time I got it to work was actually pushing with a screwdriver onto the button to make it work. That's obviously a problem with contact resistance in these gold-plated pads. So what I did was I did some measurements of the button. There's this little black pads underneath here which are conductive, and I found that if I pushed really hard I got around 1K. So that's not good enough. Currently what I've done is just put a tiny bit of aluminium tape on there to cover up the pads, and you do have to be careful doing this, because you don't want this to be in contact with the trace, because then it'll cause false activations. So I think that's a small enough amount. You just take this 3M aluminium tape, a bit of commercial advertisement there. Just get a bit of it, put it down on the table, use this little scalpel here to cut out a small square, and then very gently put it onto the trace. And as you'll see now, I'm doing this on camera, so it's definitely not going to work. There. It's now turned on. And the LCD is hard to see on camera, but it does look nice enough, and there is contrast adjustment. And it is actually transmitting. This thing is actually on and transmitting right now. And you can actually see my voice affecting it. So, right. Getting these off is easy enough. There's this little plastic thing that sort of goes around it to protect it. You have to take that off, just get a flathead screwdriver up and get these clips through. Let's see if I can get focus on that. That's as close as it'll go. You just need to get a flathead screwdriver, and then these have these little rubber penises that just sort of penetrate the board here. Getting them back on is actually the hard part. Let me turn it off and just remove this from the main board here, because by default these are almost impossible to push through the board. So just get some PTFE or Teflon lubricant, get a tiny bit on each bit of rubber. Silicone will do as well. You can just sort of push them straight through. There. Now they're mounted, and we can, again, doing this live. There's just a single bit of flex wire there connecting the two boards. We can turn that on, and there you go. Let's see if I can adjust the display contrast. That's too much. I kind of like it all the way down, actually. There's that storage. Let's set up the name. This thing supports computer control as well. But I haven't gotten that to work. I don't have the cable, and I don't think we need it anyway. So you can just choose channels there. Scan, output, squelch setting. It's just high, mid, low. You can display all sorts of stuff. I haven't looked too closely at the manual for this, but just exit the menu there. And it doesn't look like these arrow buttons actually do anything in normal mode, but we'll turn it off. So that's an easy fix for that. There are other ways of making these pads more conductive. You could use something more fancy like the sort of PCB trace repair pens would probably work pretty well. These just sort of push back on, and a small one there. But aluminium foil tape works, certainly seems to work well enough for what I want to do. Just get this thing working. We don't need, we're not going to use this a whole lot. So, okay, I'm just going to reassemble it now. In terms of tooling, what you'll need is a flathead screwdriver, a small one, to pry these off. You'll need the scalpel if you're doing the aluminium tape. You'll obviously need the aluminium tape. Some sort of lubricant to get these plastic pads back on. A Phillips 1 screwdriver to remove this from the assembly here. It's just sort of screwed in there. And a torque 10 bit driver for all the other screws. Yeah, let's give it a go at reassembling. And there you go. It's been completely reassembled and ready for use. Got the balanced audio, unbalanced audio, data connection for serial, and BNC connectors for the antennas. So I hope that was helpful to anyone interested in this sort of thing. Certainly an interesting failure mode. This looks like a very new bit of kit, very expensive bit of kit. It certainly feels extremely solidly built. So I'm certainly glad that I was able to repair it for the student radio club at my school. It should be useful.